AI is eating the world, right? But it is also like totally eating our power grid.
Oh, absolutely. It's a huge issue right now.
Yeah, so welcome to today's deep dive. We're looking at this stack of corporate strategy documents plus some technical specifications for PCS's subcritical water treatment.
It is fascinating tech, by the way.
It really is. And we also have some broader context from government digital lifeline initiatives, all to unpack this genuinely wild mission.
Yeah, it's quite the blueprint.
Right. So the question we're exploring today is, what if the solution to powering this, resource-hungry future of AI isn't building more traditional solar farms, but utilizing the literal mountains of waste plastic we throw away every single day?
It is, well, it's a radical shift in perspective, to say the least.
Totally.
To understand why this strategy, which was developed by a company called Enablus, by the way, is moving from just a concept to a real necessity, we kind of have to look at the baseline reality.
Right. The stuff established by the Ministry of Economy, Trade, and Industry, METI.
Exactly, METI. Their reports outline this just explosive demand curve for AI. I mean, we've moved so far beyond simple text chatbots.
Yeah, we're talking physical AI now.
Right. The integration of AI into robotics, vast manufacturing data analysis, and generative AI servers. And all these applications, they require massive GPU memory.
Right, and high-capacity SSDs.
Yeah, exactly.
And those components, I mean, they run so hot and require just immense constant electricity.
Immense is almost an understatement here. The physical power density of a new AI server rack compared to, like, a traditional cloud server rack, it's an entirely different beast.
Yeah.
And this explosion in power density has created a severe absolute shortage of green power.
Which is a huge problem for Japan's GX strategy, right? The green transformation strategy.
Exactly. The government heavily prioritizes securing decarbonized power sources. But the sources we're looking at reveal this fatal gap. Japan has incredible world-leading strengths in materials and device manufacturing. But there is a profound lack of power infrastructure capable of, blending that digital growth with green technologies.
Yeah, let's ground this in an analogy because the grid bottleneck is basically the core of the whole issue.
For sure.
A lot of people wonder, like, why can't we just plug these new AI data centers into the existing local grid? Maybe, I don't know, subsidize it with a few local wind turbines.
Right. Which sounds logical on paper.
It does. But it's a scale problem. It's like trying to connect a high-pressure industrial fire hose to a residential kitchen sink.
That's a great way to put it.
Like the water or the power, in this case, it might exist somewhere in the reservoir, but the local pipes will literally burst trying to deliver that kind of concentrated, continuous volume to a single house.
Exactly. The fundamental delivery mechanism just wasn't built for a sustained, massive draw like that.
So if the traditional grid and local renewables are maxed out, the juice has to come from somewhere entirely off the grid.
Which is the exact entry point for Enablus and their PPA model, the Power Purchase Agreement ecosystem.
Okay, break that down for us.
Well, they are essentially bypassing those traditional grid constraints completely. They're building a closed-loop pipeline that turns municipal waste plastic directly into energy.
And it's dedicated exclusively for data centers.
Yes, exclusively.
The financial math in these strategy documents is actually what initially caught my attention. They project this totally disruptive energy cost.
Oh, yeah. The 12 to 15 JPY per kilowatt hour.
Right, just 12 to 15 JPY. In the current market, that is an incredibly aggressive low price point, especially for a firm power source that isn't, dependent on whether the sun is shining or the wind is blowing.
Exactly. It's stable baseline power.
But, I mean, power generation usually scales in costs with fuel.
Mm-hmm.
If they're hitting 12 to 15 JPY, their fuel cost has to be practically zero. Or wait, are they actually getting paid to acquire the fuel?
You hit the nail on the head. That is the foundational economic pivot of the entire Enablus model. They do not buy the plastic. Yeah, the visual pipeline in the sources shows these garbage trucks collecting local waste plastic. Municipalities and waste management companies, they actually pay a tipping fee for someone to take that plastic away.
Because otherwise they have to pay to landfill or incinerate it anyway.
Exactly. So the fees Enablus collects for processing a region's garbage offset the capital and operational costs of generating the electricity.
Okay, so that fundamentally flips the unit economics of a data center.
Completely. Typically, energy is an operator's largest operational liability. But in this model, the raw fuel acquisition acts as an initial revenue stream.
Right.
And that upfront revenue basically subsidizes the generation process, which is exactly how the final power cost delivered to the servers drops down to that 12 to 15 JPY per kilowatt hour range.
The economic logic is super sound, but we really need to address the massive elephant in the room here.
The emissions.
Yeah. If you are listening to this and thinking about the environmental impact, any phrase like turning plastic into energy immediately conjures up images of industrial smokestacks.
Of course.
Like, if we are burning thousands of tons of plastic, aren't we just creating a massive toxic hazard?
Mm-hmm.
What about dioxins? It seems kind of counterproductive to solve a digital grid problem by creating an atmospheric crisis.
It is the most important question to ask, really, and the technical specifications go into deep detail to clarify this exact point. The short answer is no, they are absolutely not incinerating the plastic.
Okay, good. So what are they doing?
Well, to understand the mechanism, we have to separate the power generation from the waste treatment. First, the plastic goes into a pyrolysis furnace.
Pyrolysis. No.
Yeah. Pyrolysis is a process of thermal decomposition in a completely oxygen-free environment. Because there is no oxygen, there is no fire.
Ah, okay.
The plastic doesn't burn. It basically melts and breaks down into a synthetic gas and oil, which is then used to run the generators.
Okay, so a closed-loop thermal decomposition captures the energy. But, I mean, even without oxygen, breaking down mixed municipal plastics has to leave behind something nasty. Like, once you extract the synthetic gas, you're left with a highly concentrated toxic residue, right?
Absolutely. And that concentrated residue is historically the most dangerous and expensive part of plastic processing.
Okay.
But this is where the true technological innovation sits. The sources detail the integration of PCS pollution control systems, and specifically their subcritical water treatment technology.
Okay, PCS subcritical water treatment.
Yes. And here is a critical distinction we must make. This PCS subcritical water treatment is not used for the initial pyrolysis furnace.
Okay, it's not.
No. It is specifically designed for the detoxification treatment of the concentrated residue after pyrolysis.
Oh, okay. So how does subcritical water actually detoxify that post-pyrolysis sludge without using combustion?
It basically comes down to manipulating the physics of water. Normally, water boils and turns to steam at 100 degrees Celsius. But if you put that water inside a sealed, heavily engineered pressure vessel, you can crank the temperature up to around 370 degrees Celsius while the intense pressure keeps it in a liquid state.
Wow, okay.
This is what we call subcritical water. Under these extreme conditions, the physical properties of water completely change. It acts like a highly reactive organic solvent.
That's wild.
It is. It attacks the complex molecular structures of the toxic residue and hydrolyzes them, essentially snapping the chemical bonds apart.
That makes perfect sense. So you are using extreme heat and pressure to chemically dismantle the toxins at the molecular level, rather than just setting them on fire.
Exactly.
And because there is no combustion, dioxins, which are, a byproduct of burning chlorinated plastics, they're never formed.
Zero dioxin emissions. It is a surprisingly elegant engineering process. The specs note that because the subcritical water acts as such a powerful solvent, the system can process mixed waste without needing complex, expensive sorting beforehand.
That saves a ton of money.
Oh, yeah. And the operation is highly automated. It requires minimal staffing, just 2 people, including a certified boiler engineer.
And the residue that actually comes out of the subcritical water treatment, the sources mention it, is transformed so thoroughly that it can be reused, right?
Yeah, as liquid fertilizer for agriculture, or even as snow-melting agents.
That is incredible.
Yeah.
You are taking the most toxic leftover sludge from plastic processing and molecularly neutralizing it into a benign agricultural product.
Which brings us to the broader architecture of what Enablus calls their green matrix.
The green matrix.
Yeah. This matrix relies on 4 competitive advantages. Their extensive expertise in waste plastic handling, their global financial hub established in Singapore, their proprietary channels for procuring power generators, and finally, their intellectual property.
Okay, the intellectual property is where this stops being just like a novel power plant and becomes a completely new digital asset class. Enablus isn't just selling cheap electricity. They are actively tokenizing environmental value. If you are a listener working in corporate IT or strategy, you know how heavily companies are scrutinized over their ESG commitments right now. Environmental, social, and governance.
Oh, the pressure is immense.
Right, and this token strategy is aimed directly at that pressure point.
It really is. It's the intersection of physical waste management and global decentralized finance. According to the documents, Enablis applied for patents on these environmental value tokens back in 2020.
2020, they were way ahead of the curve.
Very much so. And they emphasize that this is currently the world's only mechanism for the useful utilization of waste plastic in this specific, verifiable manner.
Let's break down the mechanics of the token itself.
Mm-hmm.
How does destroying physical plastic translate to a digital ledger?
So the token captures a verified double environmental value.
Double value, okay.
Yeah. When a specific tonnage of plastic is processed through the Enablis system, the company measures two metrics. First, the physical volume reduction of the waste plastic, so plastic that was permanently removed from the environment.
Right.
Second, the CO2 reduction achieved by generating power this way compared to pulling that equivalent power from the standard fossil fuel heavy grid or from traditional incineration.
Ah, yes.
The blockchain basically creates an immutable, transparent record of both those victories and mints them into a single digital token.
And then Enablis lists these tokens on the global crypto and carbon markets through their Singapore entity.
They do.
But the real strategic hook is how they use these tokens to secure data center clients.
Yes, exactly. When a corporate client signs a PPA, a power purchase agreement to lease server space or buy power from an Enablis facility, they don't just secure those 12 to 15 JPY energy rates.
Right.
They are actually granted these environmental value tokens as part of the agreement.
It is just a brilliant incentive structure. You aren't just locking in cheap off-grid power to train your AI models. You are automatically acquiring a tradable digital asset that mathematically proves your company removed plastic from the real world.
Exactly.
It essentially turns a massive IT expenditure into a hard ESG asset.
It solves two massive corporate headaches simultaneously. Scaling AI compute without bankrupting the company on energy costs and hitting aggressive carbon neutrality targets.
Incredible.
But, understanding the tech and the tokens leads to the next logical question. How do they actually deploy this hardware in the real world?
Right, the logistics of it.
Yeah. The strategy outlines 5 distinct implementation visions based on geography and scale.
Vision 1 is what they call the flagship data center. It is a massive 30 billion JPY project planned for Bibai City up in Hokkaido.
And Hokkaido is highly strategic. It leans into a concept called snow cooling, which drastically lowers the facility's PUE, power usage effectiveness.
PUE is basically the standard metric for data center efficiency, right? It's a ratio of the total amount of power a facility uses compared to the power delivered specifically to the computing equipment.
Spot on.
And the closer to 1.0, the better.
Exactly.
Right.
In traditional data centers, up to 40% of the total electricity consumed goes solely to running the massive air conditioning units need to keep the servers from melting.
Which is just a crazy overhead.
It really is. But by utilizing Hokkaido's naturally freezing ambient air and storing massive amounts of winter snow to circulate chilled water through the server racks in the summer, they practically eliminate that 40% cooling penalty. The PUE just plummets.
And the Bibai facility combines this snow cooling with pressure-based hydroelectric power, battery storage, and the waste plastic generators to create a completely off-grid, independent ecosystem.
It's massive.
It is. The documents also outline Vision 2, which is the Sanex hub in Tomakomai, designed as a massive processing center to expand the token economy. But Visions 3 and 5 are where the strategy gets incredibly agile. We're talking about container data centers.
The micro deployments. This addresses the speed-to-market issue that just completely plagues traditional data center construction.
Right, because instead of taking 5 years to pour concrete and build a multi-story fortress, Enablis packages server racks into specialized high-density shipping containers.
Exactly. The advantage here is hypermobility and speed. The documents note a rapid setup time of just 3 to 6 months.
3 to 6 months. That's incredibly fast.
It really is. You drop the container next to the plastic-to-energy power source, hook up the data lines, and you are operational. But Vision 3, what they call bathhouse co-location, is easily the most fascinating application of these containers.
Oh, I love this part. It is a masterclass in industrial symbiosis and waste heat reuse.
Absolutely.
To visualize this, listeners, think about a high-end gaming PC. If you run a graphically intense program for a few hours, the fans kick into high gear and your room noticeably heats up.
We've all been there.
Right. Now scale that up to a commercial level with thousands of enterprise AI GPUs running at maximum capacity 24/7. The thermal exhaust is staggering.
It's a massive amount of heat.
Under Vision 3, Enablis takes these container data centers and physically drops them next to local Japanese hot spring bathhouses.
Yeah, and the mechanism here is liquid cooling heat exchange. The hot water piped away from the screaming hot GPUs isn't just vented into the atmosphere.
What a waste that would be.
Right. Instead, it is routed through a heat exchanger connected directly to the bathhouse's water system.
So the data center gets the cheap, continuous cooling it desperately needs to function, and the bathhouse gets a massive free source of thermal energy.
Exactly. Completely replacing their need to buy expensive boiler fuel to heat the springs.
It is literally integrating cutting-edge AI infrastructure into the traditional cultural fabric of a local town.
It's brilliant. And Vision 4 takes a similarly pragmatic approach to rural infrastructure. They call it agri-solar rescue.
I found this deeply interesting because it solves a problem most people don't even know exists.
Yeah.
You have these massive solar panel farms built on old agricultural land across Japan, but they are failing.
Yeah, they are failing due to the intermittency of the sun and the limitations of the local grid we discussed earlier.
Right.
The local grid simply cannot handle a massive spike of energy at noon when the sun is brightest. So the grid operators force the solar farms to curtail or shut off their production. It basically creates stranded assets.
Power's there, but there's literally nowhere to send it.
Exactly. So Enablis' solution is to drop a container data center directly onto that farmland. They pair the solar panels with a waste plastic power generator.
Oh, that's smart.
When the sun is shining, the data center runs on cheap solar. When the sun sets or the grid demands curtailment, the stable baseline power from the plastic generator kicks in.
So the data center smooths out the intermittence.
It creates a constant power curve, yeah.
Yeah.
And suddenly, a bankrupt, stranded solar asset becomes a highly profitable, self-sustaining AI compute node.
So synthesizing all of this, the technology, the tokens, the containers, what is the ultimate takeaway from these strategy documents?
The takeaway is understanding the revenue multiplier effect. This is what separates Enablis from traditional infrastructure.
Okay, unpack that multiplier for us.
Well, a standard data center operates on a very flat, linear financial model. You have immense capital expenditure to build it, high ongoing energy costs to run it, and you make your margin purely on the data processing fees from your clients.
Right. Very straightforward.
But Enablis vertically stacks its ecosystem to capture value at every single stage of the process.
They aren't just running servers, they are operating like 5 different businesses simultaneously. Let's stack them up.
Let's do it. First, at the foundation, you have government subsidies. Because this model perfectly aligns with MEDIA's GX strategy and the Ministry of Environment's push for zero-emission data centers, Enablis secures significant grant funding that heavily reduces their initial capital expenditure.
That's huge.
Second, you have the waste collection fees, the negative cost fuel we discussed earlier.
That's the garbage trucks paying them to take the plastic.
Correct. Third, they capture the waste heat from the servers and monetize it by selling it to local facilities like the bathhouses.
Right.
Fourth, they mint the environmental value tokens, capturing the CO2 and plastic reduction, generating a completely new stream of digital revenue on the global carbon markets.
And then finally, at the very top of the stack, you have the actual core revenue.
Yes, leasing out server space and data processing power for AI applications.
So one single activity processing municipal waste plastic cascades into a multiplied, highly resilient revenue stream.
Exactly. The combined profitability of this ecosystem is exponentially greater than a standalone data center. And more importantly, it achieves complete systemic independence.
Right.
It decouples the future of AI growth from the vulnerabilities, bottlenecks, and frankly, the geopolitical supply chain issues of the traditional national power grid.
It's just a remarkable closed loop. Let's recap the journey we just took today. We started with an AI industry facing an existential energy crisis, bottlenecked by a traditional grid that simply cannot support its physical density. And we explored a blueprint that flips the script entirely. A system that eats local garbage, produces its own reliable 12 to 15 JPY off-grid power, handles its own toxic residue using the molecular physics of subcritical water instead of fire.
Wait, I should say detoxifies the residue after pyrolysis.
Yes, very important distinction.
Right. And then it mints proprietary crypto tokens to verify its environmental impact and pipes its exhaust heat into local hot springs.
It really forces us to entirely redefine what a data center is and what its relationship to the surrounding environment can actually be.
It totally changes your perspective on the physical reality of the cloud, doesn't it? It proves that waste plastic isn't just a permanent pollutant. When combined with the right thermodynamic and chemical engineering, it is the raw, untapped fuel for the next generation of artificial intelligence.
It is the ultimate example of transforming a profound civic liability into a highly coveted asset. Which brings us to a final thought for you to mull over as we wrap up today's deep dive. For decades, we have viewed data centers as massive grid-draining eyesores, secretive fortresses that consume vast local resources while offering very little back to the immediate physical community.
Yeah, they've always been black boxes.
Yeah, exactly. But if this technology scales, if data centers evolve into these hyperlocal, hyper-agile utilities that actively consume your town's plastic waste, stabilize the local power grid, and provide free, sustainable heat to local businesses, will we soon see a future where towns and municipalities are actually competing and bidding against each other to have AI servo farms built in their own backyards?
A provocative, but increasingly realistic question.
Thank you for joining us on this deep dive into the Enable strategy. We'll see you next time.